In Episode 17, titled 2.1 Data Integration Strategy, Combining Sources While Preserving Meaning and Keys, the focus is how integration can either help an organization see truth more clearly or distort truth in ways that are hard to notice. The CompTIA Data DA0-002 exam often frames integration as a practical judgment problem, where the right choice depends on preserving meaning, protecting keys, and avoiding silent duplication. Integration is not only about making two data sets fit together, because the real challenge is keeping the combined result faithful to what each source originally meant. A join that looks correct can still multiply rows, shift totals, or mislabel records if grain, units, or identifiers are misunderstood. When that happens, the analysis may look polished while being fundamentally wrong, which is why integration skill is closely tied to trust. The goal of this episode is to make integration feel like a disciplined sequence of checks and decisions rather than a mechanical merge operation. A strong integration strategy starts with definitions because field names alone do not guarantee shared meaning across systems. The same label, such as status, date, or amount, can represent different concepts depending on the application, and combining them without aligning definitions produces confusion that looks like disagreement between teams. Mapping fields means writing down what each field represents, what its type is, what its units are, and what the expected value set looks like, including how nulls are used. A practical mapping also includes how fields were derived, such as whether a value is raw or calculated, because mixing raw and derived fields can create false differences. Exam stems sometimes describe two systems that both have a customer field or a revenue field, and the intended reasoning is to confirm definitions before comparing numbers. When definitions are aligned first, later steps, like choosing keys and join types, become much less risky. Keys must be identified and confirmed because keys are the glue that holds integrated data sets together, and they determine whether relationships behave as expected. A key is not just any column that looks unique, because uniqueness can change over time and can differ by source, such as when one system reuses identifiers or uses different formatting rules. Stability is the deeper requirement, meaning the identifier should represent the same entity consistently across time, even as other attributes change. It is also important to confirm whether a key is a natural key, like an account number, or a surrogate key, like an internal numeric identifier, because those behave differently across systems. Exam scenarios often include subtle key issues, such as leading zeros, prefixes, or case sensitivity, where joins fail or misjoin because the key formats were not normalized carefully. A disciplined approach treats key validation as mandatory, because if the key is wrong, everything downstream becomes untrustworthy. Grain alignment is the main defense against accidental duplication, because the grain defines what one row represents in each dataset. One table might have one row per customer, while another has one row per order, and another has one row per order line, and mixing these without understanding grain creates row multiplication that inflates measures. Matching grain means deciding what the combined data set should represent, such as one row per order line, and then ensuring each join attaches the right descriptive context without creating extra matches. When grain differs, aggregation or deduplication may be needed before merging, but those steps must be chosen based on the question being answered, because collapsing rows changes meaning. Exam questions often describe totals that jump after integration, and the intended skill is to suspect grain mismatch or unintended one-to-many joins. A candidate who can state grain explicitly is usually able to choose the safest integration option. Units, currencies, and time zones are common sources of hidden distortion because values can look compatible while representing different measurement systems. Units might differ, such as kilobytes versus bytes or minutes versus seconds, and mixing them can produce trends that are wrong by a constant factor that is hard to spot. Currency issues often include mixing currencies without conversion or mixing values captured at different exchange rates, which can change totals across regions in misleading ways. Time zone differences can shift events across day boundaries, distort peak times, and break sequence analysis, especially when logs and transactions are combined. These issues often appear in exam stems as global operations, multiple regions, or data collected from different systems, and the correct reasoning includes deliberate normalization before comparison. The key is to treat these differences as meaning differences, not as formatting differences, because they affect the interpretation of measures. Merge approach should be chosen based on the questions being answered, because different join types and merge strategies imply different meanings. An inner join keeps only records that match in both sources, which can be useful when analysis requires confirmed linkage, but it can hide missing matches and bias results toward well-matched records. A left join preserves the records in the primary dataset while attaching matches from the secondary dataset, which is often appropriate when the primary dataset defines the population and missing matches are meaningful. A full outer join preserves both sides and exposes non-matching records, which can be valuable for reconciliation and data quality investigation. The exam often tests whether the candidate recognizes when missing matches are a feature, meaning a signal of data quality or process gaps, rather than an annoyance to be suppressed. Choosing the merge approach as a policy decision, not as a default, is a sign of mature integration reasoning. A customer and order scenario is a good test case because it includes a clear one-to-many relationship that becomes dangerous when misunderstood. A customer table typically has one row per customer, while an orders table has one row per order, and an order lines table has one row per item within each order. If the analysis question is customer lifetime value, joining customers to orders makes sense, but the join must respect that one customer can have many orders. If the analysis question is product performance, joining orders to order lines makes sense, but joining customers directly to order lines can inflate counts if customer fields are repeated per line without care. In practice, dimensions like region or segment belong on the customer side, while measures like revenue belong on the order or order line side, and the join should preserve that separation. Exam stems often describe customer metrics and sales metrics together, and the correct answer depends on joining at the right level without multiplying measures incorrectly. Missing matches deserve attention because they often reveal real process gaps, data quality issues, or definition mismatches, not just technical errors. A missing match might mean a customer exists in a marketing system but not in a billing system, which could indicate incomplete onboarding or different population definitions. It might mean orders exist without a customer key, which could indicate anonymous purchases or a data capture failure. It might also mean key formatting differs, such as one system storing a prefix and another storing only digits, which creates false non-matches. Exam questions sometimes present an option to drop non-matching records to make the dataset look clean. And the better reasoning often is to surface and interpret missing matches because they affect business truth. Treating missing matches as signals supports both better analysis and better governance. Assumptions should be documented because integration decisions are not self-evident to someone who only sees the final dataset. Documentation includes which source was treated as authoritative for each field, how keys were normalized, how time zones were reconciled, and what grain was chosen for the integrated view. It also includes what was excluded and why, because exclusions change populations and can bias conclusions if not stated. In many organizations, the most damaging error is not the initial integration mistake, but the inability to explain later why two reports disagree, which often comes down to undocumented assumptions. Exam stems that mention audits, repeated reporting cycles, or stakeholder disputes often reward answers that emphasize documentation and traceability. A professional mindset assumes the work will be reviewed and challenged, and documentation is the preparation for that review. Validation should include totals, counts, and spot checks, because these are simple signals that catch many integration problems early. Counts help confirm that joins did not multiply rows unexpectedly, and totals help confirm that measures stayed stable when they should have stayed stable. Spot checks help confirm that individual records look reasonable, such as confirming that a specific customer's orders attach correctly and that dates and amounts align with expectations. Validation should also include checks for null rates after joins, because a sudden rise in missing values often signals key mismatches or incomplete reference data. Exam scenarios often describe mismatched totals after integration, and the intended response is to perform these before and after validations rather than to trust the merged output blindly. The point is that integration is a transformation, and transformations must be verified. Conflicts between sources should be handled explicitly by preferring authoritative sources, because unresolved conflicts can produce unstable or misleading results. A conflict might be two different addresses for the same customer, two different status values, or two different totals for the same invoice, and the right approach depends on which system owns the truth for that attribute. Some fields are naturally authoritative in one system, such as billing status in a finance system, while other fields are authoritative in a customer relationship system. The exam often tests this by describing inconsistent values and asking what to do, and the best answers usually involve selecting a source of truth and documenting the rule. In some cases, keeping both values with clear labeling can be appropriate for reconciliation, but only if the purpose is investigation rather than final reporting. Explicit authority rules protect trust because they prevent silent blending that hides disagreements. Lineage notes should be kept for every major integration decision so results remain trustworthy and reproducible over time. Lineage captures what sources were used, when they were pulled, what transformations were applied, what join logic was used, and what assumptions controlled the mapping. These notes are essential when data refreshes occur because changes in upstream systems can change key behavior, field definitions, or value distributions, and lineage helps diagnose why results shift. Lineage also supports governance because it makes it possible to answer questions about where sensitive data came from and where it traveled. Exam scenarios that mention repeated runs or stakeholder challenges often point toward lineage as the differentiator between a credible analysis and a fragile one. Treat lineage as part of the deliverable, because without it, the work cannot be defended. A repeatable planning checklist can be held as a mental sequence that keeps integration decisions consistent without turning the work into a rigid ritual. The sequence begins with aligning definitions and units, because meaning must match before any merge makes sense. It then moves to identifying and validating keys, including stability and formatting, because keys control match behavior. Next, it confirms grain and decides what one row should represent in the integrated view, because grain determines whether measures will be distorted. Then it chooses join types based on the analytical question and the meaning of missing matches, because join choice is a policy decision. Finally, it validates with counts, totals, and spot checks, and records assumptions and lineage so the outcome remains explainable. When this sequence becomes natural, integration stops being risky guesswork and becomes defensible reasoning. To conclude, integration is powerful because it can connect data into a richer view, but it is also risky because it can distort truth through key errors, grain mismatches, and silent meaning conflicts. Starting with definitions and mapping fields prevents false equivalence. Stable keys preserve correct relationships over time, and grain matching prevents accidental duplication that inflates measures. Units, currencies, and time zones must be normalized deliberately. Join approach must fit the question and reveal missing matches rather than hide them, and conflicts must be resolved through explicit authority rules. Documentation, validation, and lineage notes turn the integration result into something that can be reproduced and trusted when challenged later. One integration risk to watch for immediately is silent row multiplication after a join. Because it is common, it is damaging, and it can be detected early with simple before and after counts and totals. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.